In section 1 of chapter 5, we're going to first just talk about rate of change and slope. And I've kind of been talking about rate of change and slope all year long. We just haven't really put a kind of a formal name to it yet. Rate of change and slope are your two vocab words for this section. Rate of change is what? You know it. You've actually probably today said something as a rate of change and you didn't even realize it. Okay, so if you use the word difference, that implies subtracting. So like if I said, what's the difference between 5 and 3, you'd say 2. That's not really a rate of change. Okay, but you're on the right track. Rate of change is more like a comparison of the change of two quantities. So that's what we're going to write down. Comparison of the change in two quantities. If I were to write that down as an equation, it would be rate of change equals the change in the dependent variable divided by the change in the independent variable. Every time you get in your car and drive somewhere, you're experiencing a rate of change. What is it? Speed. That's right. How far you drive compared to how long it took you to get there. How much miles did you go divided by how much time did it take you to do that. You wind up with miles per hour. Okay, that's a speed. That's a rate of change. Slope is the mathematical version of what we're talking about here. Slope is calculated. Slope is usually when we're dealing with just an equation or looking at just a graph. It's, what did I say in third period? Let's see. I don't remember. Comparison of the change in y to the change in x. So my equation here would be slope equals change in y divided by the change in x. How much does y change compared to how much x changes in that same amount of time? In this section, we're using slope to help us graph equations. We need to figure out what slope is. Once we know slope, our equations can be graphed much easier than we've been graphing them so far this year. So far this year, we've been plotting points and then drawing lines. By the time you're done with the next couple of sections, you're going to be able to just graph it without having to plot points. And that's really nice because it becomes much faster. Using slope, equations that are linear. Linear means that if I look at a graph, I would see a line. Okay, you see the word line in linear. So equations that are linear have a blank rate of change. Constant. If the rate of change is constant for a situation that I give you, then it is linear. If one variable change is constant, while the other variable change is also constant, then the function is linear. So now I can give you a table of values, and we've kind of been talking about this in the last couple of chapters. If I give you a table of values and I compare how much is x changing, and then I look at how much is y changing, if x changes the same amount each time, and y also changes the same amount each time, not necessarily the same number, but the same amount each time for y, then it's linear. Okay? So all I have to do is take this table and say, how much am I changing from 1 to 4? I added 3, so 3. And from 4 to 7, how much do I change? 3. And from 7 to 10, how much do I change there? 3. And next, 3. So would you call that a constant change for x each time? Yes. For y, how much do I change to go from -6 to -8? -2, good. And from -8 to -10? Also -2. -10 to -12? Also -2. And finally, also -2. So would you call that a constant change for y? Yes. So because we have a constant change for y and we have a constant change for x, this is linear. So my answer here would be yes. For the second one, same thing, same idea. The directions are the same. Determine whether the function is linear. So I look at the change. How much do I change from here to here? I add 1 to -3 to get -2. And from here to here, 1. And from here to here, from -1 to 1, actually is 2. And then from 1 to 2, 1. All right, let's take a look at y. 11 to 15. I'm adding 4, so 4. And then 15 to 19, 4. And then 19 to 23. And then 23 to 27. Yeah, so 4. For y, would you say that that's a constant change? Yeah. For x, is that a constant change? No. So this one had a constant change while this one did not have a constant change. Is this one linear? No, it's not. Well, that's the idea. Go ahead and do the other two. Okay, what do we got for x in this one? -3, and here? -3, and here? -3, and here? -3, so that's constant, right? How about for y? +5. We got to add 5 to -4 to get +1. And here? 5, and here? 5, and the last one? 5. So would that be constant change for both variables? Yes, which means that this is linear, so my answer is yes. And the fourth one, how much are we changing here? 5, and here, and the next one, and the next one. Okay, looks good. And for y? -2, and here, -2, and here, -2, and the last one, -2. Is that linear? Yes. Good. Okay, the little blurb down below, it says the slope of each function is the change in y divided by the change in x. So as long as it's linear, we can talk about slope. If it's not linear, then there is no slope to talk about. So let's go ahead and find out what the slope is based on this equation right here, change in y over change in x. To calculate the slope, the change in y was a -2 divided by the change in x, which was 3. Because it's linear, we can say that the slope was -2/3. And that's your answer. Of course, if that was a fraction that we could reduce, then we would have to reduce it. For the second one, this one is not linear, so there is no slope to talk about. So we don't put a slope on that one. This one, though, is linear. What do we get for a slope? 5 over -3. -5/3 is the answer. And for the last one, this one is linear, so what's our slope here? -2 over 5. The tricky part is remembering that it's y over x, the change in y divided by the change in x. Okay? That's where most people make their mistakes here. So be careful about that. It's the change in y divided by the change in x. Those are your slopes. If it's not linear, do we write a slope? No. If it is linear and they ask us for a slope, it's the change in y over the change in x. Okay? You're now capable to do 8, 9, and 10 on the homework. So that's one way we can find slope using a table. Another way we can find slope is if I give you a graph. This is the one that most people remember. Slope using a graph is found, remember slope is the change in y divided by the change in x. Well, the change in y is how much do I go up from where I started. And we call that the rise. The change in x is how much do I have to go over from where I started. And we call that the run. So it becomes rise over run. to find your slope. It's fairly simple once you understand that concept and the couple of tricks that we got to remember on how to assign the sign to the numbers that we put down. So look at this graph. Are there any easy numbers, any easy points that we could pick to start at? You see any? On our line? Where? On the y-axis 1. What is the ordered pair for that point? X-coordinate comes first, so 0, 1. And are there any others? This one here, what are the coordinates here? -3, -1. And finally, there's one more up here, right? What's that one? 3, 3, yeah. Okay, so if you're given a graph, your goal is to find two easy points. The easy points are the ones that are exactly on your little grid crossings. Okay? Pick those out, and then from there, go using rise over run to your next point. So let's pick two of these. All we need is two. Which ones do you want to use? This one here and this one here? Okay, so let's start here. We got to go rise first. That's up or down. How much do we rise to get onto the same level as our point that we're going to? Well, that point that we're going to is here, so I got to rise 2, and now I'm even with the point that I'm going to. Okay, so I rose 2, so I'm going to write 2 over, that's my rise, so 2 over. Now I'm going to run. So I went up to here. How far do I have to run to land on my point now? 3. 1, 2, 3. So that's my run. It's 3. I write down 3. And then my answer, my slope is what? It's 2/3. That's it. We didn't have to use those 2 points, though. There's another ordered pair on here that we could have used. So let's use this point and go all the way to this point instead. Okay? If I'm going from here to here, then how much do I have to rise? 4. And so now I've risen all the way up to the same level as that point that I'm going to. How much do I have to run from here? 6. So 4 over 6, which reduces to 2/3. We get the exact same answer. So it makes no difference which points you pick. As long as they're easy points and you do rise over run correctly, you're going to get the same answer. There's another combination of points we could have picked. This one going to this one. Here I'm going up 2, and then I'm going to the right 3. 2 over 3 again, 2/3. Okay? It makes no difference. A couple of points down at the bottom here. These 2 little notes here are very important. You need to understand these. If you are going up to get to the next point, that's a positive change. You went up on your rise. That's a positive change. If you go down on your rise instead, then that's a negative change. So for each of these, I went up. I went up to here, or when I went to this point here, I went up to here. Each of those is positive. That's why I wrote a +2 or a +4. But if instead I went down, like if I started at this point here, and I was trying to go to that point, now I'm going down instead. I got to call that -2. Okay? So hang on a sec. If I do that, then I just rose -2. I'm going from here to here, so I had to go down 1, 2. So I write down -2 for my rise. And that's going to be over my run. Well, this second point right here, if you go right to get to the next point, that's a positive change. But if you go left, that's a negative change. So here I am, and I'm trying to go over to this point here. I got to go left, don't I? So I got to go left. 1, 2, 3. That I'm going to write down as -3. So I have -2 divided by -3. Does that simplify? A -2 divided by a -3? What's a negative divided by a negative? Positive. So this becomes +2/3. It's the same answer. I can go either way I want. I can go in any direction as long as I rise over run. And I go from easy point to easy point. Doesn't matter what I do, I will come up with the correct slope. I could do the same thing here. Here I'm running or rising -4 and running -6. Negative 4 divided by negative 6 reduces down to positive 2/3. Okay? I'll teach you guys a little trick here real quick. In our usual coordinate system, this is my x variable, and is that x variable right there positive or negative? It's positive x. And this way would be negative x. Okay? So if I go from my origin to the right, I'm going in the positive x direction. Just like if I'm going from my point to the right, that's a positive run. If I go from the origin to the left, that's a negative x direction. And if I run to the left, then that would be a negative run. Okay? Same thing is true for the y-axis. Which way is that? Positive or negative y? That's positive y. So if I go up from the origin, that's a positive y direction. If I go down from the origin, that's a negative y direction, right? These numbers on the axis are negative numbers here. Those all have minus signs on them. From the origin, I'm going in the negative direction. That's going down. So from here, from any of my ordered pairs, if I go up, I'm going in the positive y direction. That's why my slope, my rise, would be positive. If I go down, then I'm going in the negative direction. That's why my rise would be negative. Okay? So if you can remember this, then you can apply that to how to figure out which sign you use for your slope. One more thing, little trick that we'll talk about later on probably. If I read this graph like a book, meaning from left to right, which way is my line going? Up or down? As I look from left to right, the line goes up. Okay? And the slope of this line was positive. Positive lines, or positive slopes, have graphs that go up from left to right. If this was a negative slope, then we'd see a line going like this. Okay? So just be aware of that. You can instantly check your graphs just by knowing that little fact right there. If you graph something that should have a positive slope, you should at least see a line that goes up from left to right. If it's supposed to have a negative slope, then you should at least see a line that goes down from left to right. Okay? It's very easy to check that. Okay, these two notes right here, incredibly important. Rise up is positive, rise down is negative, rise right is positive, or sorry, run right is positive, run left is negative. So, we have 4 graphs sitting in front of us. We want to calculate the slope of these lines using rise over run. The first thing we need to do is find easy points that are on the graph, because they're not just going to give them to us. So we got to find them. Do you see on this graph right here any easy points? So you're seeing right here? Okay. We can put a dot right there because that looks pretty easy. Looks like it's right on the intersection of grid lines. Any other points that we could? 2, 1, definitely. We could go from here to here. We only need 2 points. Okay? You're right though. There is another one right here. That one seems to be crossing on a grid. Are there any others? Up top, yeah. This one right here seems to be crossing on a grid. All you got to do is find 2 and then write your slope. And then reduce your fraction if you have to. Okay? I'll go with the first 2 that we picked. This dot and this dot. So from here, do rise first. Are we going up or down? Up. So that'll be a positive. Up how far? 1, 2, 3, 4. So I'm going to write 4 over. Now from here I run, how far? 2 to the right. And is that positive or negative? So I'm going to write down 2. Now I have 4 over 2. What do I do with that? Reduce. 4 over 2 reduces down to 2 over 1, which reduces down to just 2. So I can write an answer of 2 as my slope. All right, let's do the one on the right of that. We need to find 2 points, nice and easy. Find one. Three what? 3, 1 is one of them, okay. And find me another, anywhere. 0, 2, right there. That looks pretty good. And it just so happens that there was another one over here. Doesn't matter, we don't have to use it. So, which point do you want to start at? The 2? Okay, 0, 2 right here. So I'm going to rise, how far? -1, good. We had to go down 1 to get on the same level as my other dot. So from here, Run to the right, 3. So that's a positive 3. My slope is what? Negative 1 over 3, which is negative 1/3. That's it. There's no reducing to be done there. So that's your answer. Okay, go ahead and try the other two. For the one on the left, we need 2 points. Give me one of them. 3, 1 is right there. 1, 3. X coordinate comes first, and then the Y coordinate. So we have a dot there, and give me the other one. 2, negative 2. Perfect. There's my other dot. Okay, doesn't matter which dot you start at. Which one do you want to start at? The one above or the one below? Above? Okay, here we are. Where do we go? Down 5. So I'm going to write negative 5 divided by. So here I am. Now I go right 1, so it's going to be over 1, which is just negative 5. Good. Okay, last one. I need 2 points. Give me one of them. 0, 3, perfect. And one more. Negative 3, negative 1. There it is. Okay, so pick a point to start at. Left or right? Left one? Okay, here we are. Where do we go? Up. 1, 2, 3, 4. So I write down 4 over 3. 4/3 is the answer. Does that fraction reduce? No. If it did, we'd have to reduce it. You always reduce your fractions. Okay, now label each point you used above as an ordered pair. You can also use ordered pairs to find the slope, and that's what we're going to do next. So each one of these ordered pairs that we used, we want to write down those coordinates. So this one right here, what was this one? This is just good practice here. What's this one right here? 0, negative 3, good. And this one? 2, 1, okay. And this one? 0, 2, and this one? 3, 1, okay. And then this one? 1, 3. And this one? 2, negative 2. And this one? Negative 1, 2, 3. Negative 1. And the last one? 0, 3. Okay? So identifying ordered pairs on graphs is an important skill also. We're going to be using ordered pairs here after we work on these problems right here. 6 problems. Shouldn't take too long. We're just reading things off graphs just like we just did. Go for it. So now we have finding the slope using a table, just looking at the change in y divided by the change in x. We have finding the slope using a graph, using rise over run. And now we have finding a slope from ordered pairs. I don't even have to give you a graph. I don't have to tell you anything. All I got to do is give you 2 ordered pairs, and you can find the slope between those 2 ordered pairs. Using the slope equation, which is starting to be right here. Slope is the change in y over the change in x, which we also called rise over run. From now on, we're going to use the letter M to represent slope. And every year, somebody usually asks me, why do we use the letter M? Anybody ever wondered that? Yeah? Maybe? The answer is people have spent like lots of time trying to figure out why we use the letter M. Somebody somewhere must have started it. And the best theory out there that hasn't been shot down more than any of the others is that the first person to call it M just picked it randomly. There is no reason why. They just said M. So that's why we use M today, for somebody's whim. Okay, so we use the letter M rather than writing slope all the time, so I could write M equals instead of slope equals. Now imagine you're given 2 ordered pairs. Here's your first ordered pair. Here's your second ordered pair. And that's why we call this x1, y1, and this one x2, y2. Okay? The little subscript here is just telling me that this is coming from the first ordered pair. This subscript is telling me it's coming from the second ordered pair. If I have those two ordered pairs listed like that, then the slope equation is this guy right here. M equals y2 minus y1, so the two y coordinates being subtracted, divided by the two x coordinates being subtracted, x2 minus x1. If you can memorize this, then you're going to be in a good position for this chapter, because you're going to be doing this all the time, calculating slope using two ordered pairs. It's m equals y2 minus y1 over x2 minus x1. Just say it to yourself a few times the next couple of days, and you'll have it memorized no problem. Okay? This has to be as automatic as blinking. You got to know it. It's one of many formulas that you're going to have to memorize this semester. It really doesn't matter which point you call, 1 and 2, but once you call the first point, point 1, and the second point, point 2, you got to stick with it. Okay? So what I recommend is just start doing it one way and then always do it the same way every time. So like for me, the first ordered pair that I see, like I would see this ordered pair first, I'm calling that one my first point, and I see this one second, so I call that one my second point. And then I don't get confused when I'm trying to enter things into this formula. Okay, so that's what I'm trying to say here. Just come up with a routine and stick to it. It'll prevent mistakes. All right, so we have 9 practice problems here, arranged in kind of like a tic-tac-toe board. We're not going to play tic-tac-toe. We're just going to go ahead and try to solve these 9 problems. So, for some of you who haven't done this before, I'm going to recommend that you write down the formula first. M equals y2 minus y1 over x2 minus x1. After a while, after you've written that down a few times, you'll have it memorized and you won't need to write it down anymore. I'm also going to recommend that above the ordered pairs, you decide which one is point 1 and which one is point 2, and then above them you write x1, y1, x2, y2. So for me, I'm going to write x1, y1 there, and I'm going to write x2, y2 there. And all that does is it reminds me which one's which is going to help me not make mistakes when I try to calculate the slope. Because now all I have to do is look at my equation right here. This tells me m equals y2. Well, what is y2? It's 5. It's right here. y2 is 5. Then I write the minus sign, and then I go looking for y1. What is y1? 0. Divided by x2. Well, what's x2? x2 is 1. And then I write the minus sign, and then I go looking for x1, which is negative 2. So I write down negative 2, and it's okay that I have 2 minus signs stuck next to each other like that. Think back to August. When we first started this class, one of the first things we did in here was remember how to work with subtraction of numbers. When you had minus minus, what did we do? You change, keep, change, right? Keep, change. And now it's an addition problem. You can do that with any subtraction problem. So now we simplify that. What's 5 minus 0? 5. And then 1 plus 2 is 3. Does 5/3 reduce? Nope. So that's my slope right there. That's my answer. So let me show you off to the side here what that would look like on a graph if I graph this real quick. We have negative 2, 0. Here's negative 1. Here's negative 2, 0. And then 1, 5. So 1. And then 1, 2, 3, 4, 5. Right there. If I draw a line, and we'll pretend that's a line, and I wanted to calculate the slope based on what we just did before we got to this, I'd go from here and I'd rise, how much? 5. And I'd run, how much? 1, 2, 3. So I'd have 5 over 3 as my slope. So even on this terrible sketch right here, I could still come up with the slope. Or I could use the slope equation and get that answer without having to deal with all that. Okay? So the slope equation does work. Let's go ahead and try the second one. What am I going to write? M equals. Maybe we're not good enough yet, so we don't have it memorized, so we're going to write the whole formula. What is it? y2 minus y1 over x2 minus x1. Okay? So now what should I do? I should label them up here because I'm not that strong yet in doing this. So I'm going to write x1, y1, x2, y2. Okay, now I can start filling them in. M equals, what's y2? -3 minus 4 divided by 2 minus -3. Good. Write the minus sign first and then write down the number. That way you won't lose negative signs here. Now we can simplify that. What's -3 minus 4? It's -7. Good. Divided by? Yep, we got a change here, and we get 2 plus 3, which is 5. -7/5. Does that reduce? Nope. Circle it, and you're done. All right, talk me through the last one. What do I write? M equals, and maybe we're good enough now. We don't have to write that formula down. Maybe I'm not good enough yet. I still have to label. Good. So x1, y1, x2, y2. Okay, M equals what? Very good. Divided by? Okay. Equals. What's -1 minus 1? No. It's -2. If you get confused on the subtraction, you can always change. And now it's -1 plus -1, which is obviously -2. Divided by change, and we get 5. Does that reduce? Nope. So that's my answer. All right, let's talk our way through these three problems here. What do I write? M equals 8 minus 6 divided by 4 minus 3. What's 8 minus 6? 2. What's 4 minus 3? 1. Does 2 over 1 reduce? Yes, 2. Good. Okay. So notice that time I didn't write down any of those labels. If you still need to, write them down, okay? We're just trying to go a little bit faster because we're short on time. How about this middle square here? What do we get? Yep. A -2 minus -2. Be careful with those negative signs. Divided by 0 minus -4. Okay? Write down the minus sign first, then go find that number and write it down exactly how you see it. Then you can do change all you want. So inside the top we have -2 plus 2, which is 0, divided by 0 plus 4, which is 4. Does that reduce? Yes, to what? 0. That's right. So in this case I'm drawing a square around that 0 so that it doesn't look like an egg. You can divide 0 by anything. Anytime you take 0 and divide it by something, you're still going to get 0. Okay? That's legal. How about the next one? M equals what? 10 minus 6 over -1 minus 5. Okay, 10 minus 6 is 4 divided by -6 is right. Does that reduce? Yeah, what do we get? -2/3 is the answer. Okay, bottom row, real quick. 11 minus 3 divided by -1 minus 4. So, we get 8 over -5 is correct. Does that reduce? Nope, so that's the answer. Okay, that's the slope. And the middle bottom, 4 minus 2 divided by, good, -6 minus -2. So in the numerator, what do we get? 2 divided by, change, -6 plus 2 is -4. Does that reduce? To what? So you could write 1 over -2, or you could write equals -1/2. That negative sign can go to either the top or the bottom, or it can be written out front in the middle. Okay? One or the other, but never both. And the last one. M equals -3 minus 8 divided by 4 minus 4. Okay, what's the numerator? negative 11 divided by 0. What do we get there? It's not 0. It's not negative 11 either. It's not no solution, but now you're on the right track. Can we ever divide anything by 0? No. It doesn't matter what this top number is. We can never have division by 0, ever. It doesn't matter if you're in Algebra 1 or Calculus. Can't ever do it, okay? So in this case, we can't divide by 0 because division by 0 is undefined. So we're going to write undefined. It's not no solution. That's not a correct answer. We have to say undefined when it's dividing by 0. So here we had 0 divided by a number, and we get 0. Here we have a number divided by 0, and we have to write undefined. Okay? At this point, you're capable of doing the homework assignment all the way through number 22. Get that done tonight. You're almost there anyway. You should only have like 6 problems left. Won't take too long at all.